So suppose I have two finite sets. Set A has the elements of 1, 3, 5, 7, and 9, odd digits. And set B has 2, 3, 5, 7, prime digits. Now, the symbol that's written at the bottom of your screen right now, that symbol that kind of looks like an upside down version of the union symbol, that's the symbol that we use for intersection. So the intersection of two sets is the elements that are in both at the same time. So as I'm looking at these, 1 is in A but it's not in B. 2 is in B but not in A. 3 is in both. 5 is in both. 7 is in both. And 9 is in one but not the other. So my actual answer to this is going to be the set of 3, 5, and 7 listed out, and so we use the curly braces. Now there is another way we could organize our information here, and it might not be necessary in a problem like this, but I want to point out this organization because it works nicely for what we're going to be talking about after this. We could have looked at each of our sets on the number line. So we could have looked at 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we could try to represent set A and set B here. So I'm going to go ahead and use blue to represent set A. Set A was 1, 3, 5, 7, and 9. And I'm doing this above the number line on purpose, and I'll explain why in a second. Set B, also above the number line, was 2, 3, 5, and 7. And so if I want to figure out where the intersection is, this visual representation hopefully makes it easy because I can just look at each number and say, do I have blue and red above it? So when I'm looking at 1, I can see that blue is above it, but red isn't. If I look at 2, red is above it, but blue isn't. But when I look at 3, they're both there. When I look at 5, they're both there. When I look at 7, they're both there. And when I look at 9, blue is above it, but red isn't. And so this tells me 3, 5, and 7 are the numbers that have both A and B stuff. So 3, 5, 7 is the intersection.